Hey, what's up? This is Randy. Today we're going to learn to reflect functions. More specifically, we are going to learn how do these reflections manifest themselves both algebraically and graphically. Here we go. So we're going to start today by talking about the three basic types of function reflections that you could see. And then we'll do some examples in order to help us practice what we learned about those three basic types of reflections. So here we have four different graphs, but we're going to start right up here on the top left. And it says f of x is equal to the square root of x. Now we could use many other functions to demonstrate these reflections, but I chose to use the square root of x because it's really nice to demonstrate on the graph because it only shows up in one quadrant. You can see that it's just in the first quadrant right here. The reason that's nice is because when we reflect it, such as in this case, or this case, or this case, it's really easy to see where it reflected to. And when we have a function that shows up in like 3 or 4 quadrants, those reflections start to look really messy. So it'll be easier to explain this way. Okay, so this graph on the top left is before we do any reflections, okay? So f of x equals the square root of x is our core function in this case. Now, there are three types of reflections that you could see in this lesson. The first one is negative f of x, and soon we're going to write something here on the right as well. The next type of reflection is f of negative x. We'll talk very specifically about each of these. And the last type is negative f of negative x. All right, so let's start up here on the top right with this first type of reflection. So this first type of reflection is saying that we make the entire function negative. So when we start with the graph, the square root of x, the reflection in this first case would be negative square root of x. You can see that the entire function on the right has a negative in front of it. Now, what does this type of reflection look like graphically? Well, you can see that we started going to the upper right, you can see in that first graph, and then now we're going to the bottom left. So what did we do? We just reflected over the x-axis. That's what we did. We reflected over the x-axis. So if it helps you, another way to think about this is that all of the x values remained the same, but all of the y values became negative. You can see that we are now below the x-axis. So when you see negative f of x, just think reflection over the x-axis. All right, the next type of reflection is f of negative x. What do we do algebraically here? Now in this case, we do not make the entire function negative. We only make any x's in the function negative. So we're going to have the square root of negative x. There it is, the square root of negative x. Hypothetically, if we had other x's in the function, then each of those x's would become a negative x. Now, graphically, what does this look like? We just reflected over the y-axis, right? Here was the core function, and then we reflected over the y-axis in order to get this reflection. There it is, it's a reflection over the y-axis. Another way to think about this is that the y values remained the same, but the x values became negative. All right, and that brings us to our last type of reflection for today. Negative f of negative x. It's like a combination of this reflection and this reflection. So this time we need to make the entire function negative and additionally make each x negative. And that order does not matter. So this negative makes the entire function negative, and this negative makes our x negative. So there it is algebraically, but what did we do graphically to go from this graph to this graph? We reflected, first of all, over the x-axis, and then we reflected over the y-axis, right? And once again, that order does not matter. So pretty soon you'll see that the graphic dimension of these problems is often easier than the algebraic dimension because you can oftentimes just visualize where is the graph going to reflect. But if we have a function that has multiple x's, then we have to be really careful with each of the negatives and to make sure that we don't put a negative in the wrong place and that we don't forget any negatives. Okay, so with all this in mind, let's go into the first example. All right, this looks like a lot, but it's not as bad as it looks. So let's read through it. Express the following function algebraically as a reflection across the x-axis, then across the y-axis, and then across the x-axis and y-axis simultaneously. And just like we talked about above, once again it says the three possible types of function reflections in this case are negative f of x, f of negative x, and negative f of negative x. So all this is saying is to do with this function what we did above with the square root of x. So for the first part of the question, we're going to make the entire function negative, and then for the second part of the question, we will make every x negative, and then for the last part, we will make the entire function negative and every x negative, and simplify in each of these wherever we can. And the nice thing is that the order that we did each of these explanations is the same order that we are being asked to do our process here. X-axis, then y-axis, then both. All right, so here we have represented each of the three types of reflections that we need to do. This first one is the reflection across the x-axis. The second one is across the y-axis, and this third one is across both. So just like in the explanations above, we need to apply a negative to every term in this function. All right, there it is. And when we have a negative in front of the parentheses, it's the same as saying a negative 1. So now we just need to distribute this negative 1 to each term inside of the parentheses and simplify. All right, there it is. Negative 1 times x cubed gave us a negative x cubed. And then negative 1 times negative 8x squared gave us a positive 8x squared. And negative 1 times 4 gave us a negative 4. All right, first part finished. Now, when we represent this function as a reflection across the y-axis, we need to make every x in this function a negative x. So we had two different x's to turn negative. Here's negative x once, and here's negative x again. Now let's just simplify real quick. So when we have negative x to the third power, when we simplify, that negative remains because the exponent is odd. Now, in the second case of x in this function, we had a negative x squared. A negative times a negative is a positive, so that negative disappeared, and we still have that negative in front of 8, just like in the original function. And lastly, in this case, nothing happens to the 4 because there is no x in that part of the function. All right, so there is our algebraic representation of the function when we reflect across the y-axis. And finally, let's do both of those processes combined in order to get the last part of our answer. So just like we discussed in the first part of this video, when we have negative f of negative x, we need to make the entire function negative by multiplying every term by negative 1, and we also need to make every x into negative x. Now you can see that what I have inside of these parentheses is the same thing that I had with f of negative x right here, and we know that that simplified into this expression right here. So with that in mind, let's replace this part inside the parentheses with what we had here immediately. Okay, nice. So the inside of the parentheses is now simplified, and we just need to distribute this negative 1 to this term, and this term. In other words, we're just going to change the sign of each term. And there it is. We have now done exactly what the question asked us to do. We have represented algebraically a reflection over the x-axis, and then the y-axis, and then both the x and the y-axis. All right, that was a long problem. Let's do one more really fast example, then we'll be done. Consider the two parabolas below. Which type of function reflection was applied to the green parabola, we're calling f of x, in order to render the blue parabola, which we're calling g of x? And as we know, the three possible types of function reflections in this case are negative f of x, f of negative x, and negative f of negative x. So immediately you should be able to see that to go from this parabola to this parabola, we first reflected over the x-axis and then over the y-axis. So it went here and then over here. And you could always think of it in the opposite order. You could think of it as over the y-axis first and then over the x-axis. But the point is that to go from this parabola to this parabola, we reflected over both, which means that the type of reflection that we observe in this example is negative f of negative x. And that's the answer. Negative f of negative x is the type of function reflection that was applied to this parabola in order to get this parabola. All right, and now that we have learned about the three basic types of function reflections, which include negative f of x, f of negative x, and negative f of negative x, we are finished. Hey, hey.